In this video, we're going to find the interval of convergence for the following power series. And to do so, we apply the ratio test, limit as k goes to infinity, of the absolute value of the a sub k plus 1. So k plus 1 times x to the k plus 1 over a sub k. So k, x to the k. Now we need to do a little bit of algebra to be able to simplify this thing. So limit as k goes to infinity. So we'll have the k plus 1. Now this one, x to the k plus 1, I'm going to rewrite as x to the k times x. And on bottom I've got k, x to the k. And I can see that I can cancel out those x to the k's. Now this term here doesn't depend on k, so I'm going to pull it out front. And I do need to still observe the absolute value. And I've got times the limit as k goes to infinity of k plus 1 over k, which no longer needs the absolute value because it's going to be all positive. One round of L'Hopital's rule will show you that this limit is going to go to 1. So I get the absolute value of x, and remember, the ratio test says I have convergence if this is less than 1. So right now, I have that x has to be in between -1 and 1. But because the ratio test is inconclusive at 1, I need to test those separately. So first off, let's test x equals -1. And plugging that into my series, I would get k times -1 to the k. Well, we can very quickly show that the limit as k goes to infinity of k does not equal 0. So it's divergent by the divergence test. What about 1? So k equals 1 to infinity. I think we're going to have something pretty similar, because this time we're going to get k times +1 to the k, which is actually even worse because now it's not even alternating. Once again, we know this does not equal 0. So once again, divergent, both of them, by the divergence test, or test for divergence, whatever you like calling it. So our interval of convergence for this particular series is -1 to 1, not including either endpoint.